Okie dokie. Welcome to homework 6 for 1026, starting with number 1. Let's see how many questions we can get through here. Find the general solution to this. Okay, so we're using a method known as separation of variables. So they call it separable differential. That's annoying. It's called separation of variables. So what you do is get all the y terms onto the left side of the equation, which kind of looks like they already are, and get the x terms on the right side. So what we do is we're going to leave the 7y dy, but we're actually going to multiply this dx, really multiply by dx on both sides. So it's multiplying it over to the right side. And we have the y's with the dy's and the x's with the dx's. And the intention here is to then integrate or find the antiderivative of both sides. When we do so, on the left side, we get 7y squared over 2. No need to add plus c over here as long as we do it on the right side. We have the integral of 2x squared, so 2x cubed over 3. And again, add c. So you just have to add c onto one side. Typically just stick with the right side. And then our goal is to solve for y, or in this case maybe y squared. We'll see what they have us do here. I'm guessing it's just y squared since we don't see any square roots. So how do we get y squared by itself? We're going to multiply by the reciprocal 2/7. So we're multiplying this whole side by 2/7, and that'll cancel out that, so we'll be left with y squared. And then when we multiply 2 over 3 by 2 over 7, that would be 2 times 2, which is 4, and 3 times 7, which is 21x cubed. And then my guess is that they're doing c times 2/7, which is really just another constant. And so they're going to write it as just plus c, not 2/7 c. So it's another c, so just be clear that this c is not the same as that c. Okay? But 4 over 21x cubed plus c, that's looking like option B here. And make sure it's equal to y squared, not y. Okay? That's the first one. Let's go to number 2. Solve this. So solve for y given this differential equation. So again, we want the y's on the left side and x's on the right side. So we're going to divide both sides by y. That's going to give us a 1 over y dy on the left, while also multiplying over the dx. So we have 5x to the 4th dx and 1 over y dy. Once we have it separated, we integrate both sides. The integral or antiderivative of 1 over y is the natural log of the absolute value of y. On the right side, 5x to the 4th goes to 5x to the 5th over 5. Those cancel, and so hopefully it's clear to see it's just x to the 5th, because x to the 5th has a derivative of 5x to the 4th, right? And don't forget to add c. Now, we want to solve for y. We're typing an exact answer. So all we do is eliminate the ln by making e the base of both sides. The e and ln cancel. At that point, you can just be left with y. And then we could write it as e to the x to the 5th plus c, but they will often, like when I say often, I mean 100% of the time, break up that addition within the exponent as multiplication of two terms, both with e as the base, but the x to the 5th as one exponent and c as the other exponent. And then they'll go a step further and say, well, e to the c is really just another number. Just like in the last one where it was like 2/7 times a constant is just another constant. Same thing here. E to the c is just a different constant. So they will call it c, this will be the new constant c, and then e x to the 5th, e to the x to the 5th. Okay, so this would be our final answer. Now, I'm curious if they want you to type c in there or just e to the x to the 5th. Whichever is probably good. I mean, yeah, I don't know. They don't really mention the c, so maybe just try the e to the x to the 5th, and then if that doesn't work, then do c. But typically, it's good practice to have the constants in the mix, but let's keep it going. Find the general solution for this differential equation. Same process. Multiply the ey to the other side, so we have e to the y dy. Multiply the dx over. You have 2e to the x dx. Integrate. E to the y has an integral of just e to the y. 2e to the x, same thing, 2e to the x plus c. Eliminate the e, so we get y by itself by taking the natural log of both sides. Now, when we do this, it's going to be a little weirder, but we'll have y equals Can we rewrite this? What's the best way to go about this? Shoot, I mean, you could probably just leave it like that. I'm trying to think of a clever way to simplify it, but with that plus c on the inside, I don't really see a great way to simplify it. If it was just the 2e to the x without the plus c, I'd say you could simplify it to end up just being, I think, 2x. But I mean, if they're allowing you to leave it like that, I would just leave it like that. Yeah. All right, let's keep it going. Number 4.